So there is a connection between factoring, which gives you zeros, and the lead coefficient test. So yesterday you were just kind of practicing, but now today I'm going to show you how those two things are related. Okay, let's refresh about zeros. Zeros is another word, okay, aka x-intercepts. And so where that graph will cross the x-axis. Also called roots. Those words are all interchangeable with each other. So if I say how many x-intercepts does it have, I'm really asking how many zeros does it have or how many roots does it have. They all mean the same thing. It's called a zero because you set the equation equal to 0. You also set the factor parts equal to 0. That's why it has its name of 0, but that's how you get it. Okay, the degree is the same thing as the power, which equals the number of zeros. So there's all connected together. If the degree is 4, then there will be 4 zeros. We talked about curves. There will be one fewer curve than the power. Okay, one fewer curve than the power. So let's talk about problems like this. Okay, problem like x plus 3. What's the power on that? Power, I'm sorry? 1. This is power 1, which means it has 1 0 and no curves. Does that make sense? What's the graph of something with no curves? A straight line. And that's right, that's what x plus 3 is. But if you make x squared plus 3, that's power 2. That's going to have 2 zeros, and it's going to have 1 curve. And what's its graph look like? What does x squared plus 3 look like? And that has 1 curve, right? A parabola has 1 curve, and it crosses the x-axis twice. Okay, or x to the 3rd plus 3. That's power 3. And so that's going to mean, because it's power 3, it will have 3 zeros and 2 curves. Now, as Dylan was noticing, sometimes you can't see all the curves because they're microscopic little teeny curves, but they are all still there. So no matter how high up you go, there's a connection between the power and how many curves there are. Okay, so let's see how this all connects together. I would like you to, we're going to work together to sketch the graph of x minus 2, and x plus 2. When I say sketch, it means you only need an x-axis and you don't need a y-axis. Okay, you only need an x-axis, you only need a y-axis. Okay, now, how many zeros are there? No? There's one number 0. Okay, I don't mean how many number zeros are there. How many zeros or roots or x-intercepts are there? How many solutions are there? There are 3. Okay, so our roots, we can call them that. We can call them x-intercepts. We can call them roots. There are 3. There should be 3. Okay, the 3 come from the 3 different factor parts. There's a factor part. Whoops. There's a factor part, there's another factor part, and there's another factor part. So there are 3 roots. The 3 roots are 0, 2, -2. Well, if there are 3 roots, how many curves should there be? Okay, there should be 2 because there's always 1 less. And so we are going to sketch this. Okay, we got 3 roots, we have 2 curves. I want to know about the leading coefficient. Now, how can you tell the leading coefficient if it's not all foiled out? Well, you got to think, fast forward in your brain, what the result of the FOIL would be. If I superfoiled this all together, it's going to take the leading term of each factor part. Okay, what is the leading term of the first factor part? It only has 1 term. What is it? The first factor part, what's its lead term? Not 1, it's x, 1x. Okay, what's the leading term of the middle factor part? 1x, and what's the leading term of the last one? Put them all together. What do you have? X cubed. Okay, what's the leading coefficient on x cubed? Positive or negative? Okay, it's positive. All right, so the leading coefficient is 1x cubed. If it's positive, we know that the right side is going up, and we know that the left side is going down. Whoa. Okay, now we have everything we need to sketch. So you have to think first about your roots, think second about your curves, and then think about your lead coefficient, and then you're ready to sketch. All right, make a x-axis on there. You do not need a y-axis when you're sketching. You start with graphing the roots, so 0, 2, and -2, and those are going to be critical dots on that x-axis. Our right side should go up, our left side should go down, and we should have 2 curves in the middle. And so we create a sketch that does that. Okay, let's make our right side go up. The right side means the critical dot, that's the farthest on the right. From there you go up. On the left side you go down, so you go to the critical dot, that's the farthest on the left, and that's going to go down. And then we need 2 curves in the center. And there your graph is finished. That's a sketch. No y-axis needed, just an x-axis. All right, now let's try another one. Okay, sketch -x squared, x plus 2, x minus 2 equals 0. All right, let's kind of think about those same things. Let's think about the roots. Let's think about how many curves there should be. Let's think about what the lead coefficient is going to tell me. Let's start with the lead coefficient. Because this is broken up into parts, I need to look at the lead coefficient of each part. Okay, so I still have the part here, here, and here. Take the lead coefficient of each part and put them all together. So the lead coefficient of the front piece, there's only 1 term there, that's -x squared. The lead coefficient of the middle term, x. The lead coefficient of the last part, also x. Put them all together, what do you get? I get -x to the 4th. That would be all the leads combined. So what does that tell me if that turned out to be negative? There's a reflection. And if there's a reflection, the right side has to go down. How do you know and the left side? It's an even one, and so the left side is down also. All right, so you can tell all of that from your lead term. It's a reflection, the right side's going to go down, the left side is going to go down. And what's the power again? 4. So my roots should be how many? No, it should be 4. The roots have to match the power of the lead coefficient. And so then the curves should be how many? Okay, there should be 3 curves. Okay, let's find our roots. Let's look at the pieces. Let's work backwards, if you don't mind. Okay? What's the 0 from the last part? The last parenthesis. What's the 0 from that? 2. Okay, what's the 0 from the middle part? Okay. What's the 0 from the front part? How many am I supposed to have? I only have 3. Okay, what's the problem? Okay, here's where you got to trust your math. Okay, let me show you. Don't just be hypersensitive. Be smart about it. Okay, how'd we get the first one? You guys said 2 right away. How'd you get that? Like, tell me the math that makes that work. Okay, start with x minus 2, make it be equal to 0, and do what to both sides? Add 2, right? And so we get x equals 2. Okay, yep. And then we can take the middle one, and we trust our math, and we minus 2 to both sides. Okay, your last one. Okay, what do you do to both sides? First, what do you do to both sides? You got rid of the negative. Okay, so that's going to be x squared equals 0. Then what do you do to both sides? And what goes in front of every square root? Plus or minus, even in front of 0. And so the answer is plus and minus 0. It's not just plain old 0. So we go back to our list, and we don't just have 0, we also have negative 0. And that's something we've never talked about before, that there is a positive 0 and then there is a negative 0. All right, well, how do we graph those and sketch them on a number line when you have plus or minus 0? Okay, well, we know how to put most of these on. Okay, so there's 2, and negative 2. All right, when you graph 0, to the naked eye, you're only going to see one of them. But like, whoa, put a microscopic or like a star or something to yourself there. That is something special. To the naked eye, you wouldn't be able to see it, but you're going to have to know this is something called a double 0 or a double root. Some people call it that. Other people call it, it's multiplicity. Like if you, a multiplicity means you have multiple of them. And we have multiplicity 2. We've got 2 of them. That's the same spot. What that means is that you have your extra curve is happening right there. It's an extra curve that you wouldn't normally have. Okay, so let's draw it. Right side down, left side down. Right side down, left side down. Come on. Okay, there needs to be a curve between 2 and 0. There needs to be another curve between negative 2 and 0. And so it looks like they're going to collide at 0, but they're not. There's going to be another turn right there because we put a star by it and we identified that as a double root. And so what it looks like when it comes in like that is it's an extra turn. So it's going to come down and just turn through there like that. So it's not a collision, it's an extra turn. And that's how we get this W shape that we expect to see for a degree 4. That only happens when you have multiplicity 2. It doesn't happen on multiplicity 3. Actually it happens on multiplicity evens. That you're going to have an extra bounce right there. Okay, let's try another bounce, one that has that extra curve. How about one like this? How about sketch x minus 1, x plus 3 squared equals 0. soon as you see that square, you should be thinking, ooh, something's important about that. But let's write down, okay, we have our roots, our curves, our LCT. Okay, our roots, our curves, our LCT. Sometimes I'll start with the LCT. I kind of like to do that. Okay, start with that LCT. Diego, can you get me an LCT for this, the lead coefficient? That's the lead for the front, but that's not how I get my overall lead. Okay, so let's think about that. You've got your x for the front, right? And then you've got your x for the middle. And then you've got x plus 3, which has its own square on it. What does x plus 3 squared mean? There's 2 of them. So maybe it needs to be better if we erase the x squared and we write it twice. Like this. There's 2 of them. There's not just one. All right, so Diego, that's going to affect your answer. What is the lead coefficient? Not plus 5. No, you can't combine those numbers. Okay, there's nothing that says we can combine the numbers. We can only combine the first part of every factor. All right, so what's the lead term here? What's the lead term of this section? What's the lead term of that one? And the lead term of that one? Therefore, there we go. All right, so the lead term is x to the 4th, which means there's no reflection, which means, what about the right side? Okay, Ashley, what do you think? What's the right side going to do? It's going to go up. And what's the left side going to do? It's also going to go up. And if the lead term is x to the 4th, Sarah, you okay? Okay. I'm going to ask you a follow-up question, so just be ready. Okay, so Ryan, how many roots will there be? There are going to be 4. Okay, there should be 4. Remember, they have to exactly match the lead term. Okay, so Sarah, how many curves will there be? There should be 3. Good. All right, Mia, you want to give me one of the roots? Uh-huh. 0. Are you feeling confident about another one?
1.
Okay.
Negative 3.
Negative.
-3, and then
Okay, so I need 4 of them, though. What's the 4th one? Negative 3 again. All right, and so that is going to be another double root, multiplicity 2. So that means I'm going to have an extra curve there. Okay, so we sketch it. I have 0, 1, and then 1, 2, negative 3. And put a star or something to yourself about the negative 3 to remind yourself that there's an extra turn going on there, an extra curve. We know that our right side goes up, our left side goes up. There has to be a turn between 0 and 1. There has to be another turn between 0 and 3. But at 3, then, there needs to be my last turn. And so there is a turn right there also. How would you describe the difference between what's happening to the graph here right at 3 versus what happens at 0 and 1? How would you describe what happens here? So like this, I would say it crosses over, right? It's like it crosses through to the other side, and then on this one it crosses through to the other side. But what does it do at negative 3? It like bounces off, right? And that's where that always is going to happen at one of those multiplicity 2s, where it just bounces right off of that curve rather than passing through to the other side. Okay, just 2 more and try with you. All right, let's sketch. Negative 2x cubed minus 2x squared minus 4x. So let's make a list. We need to know roots. It helps us to know curves, and it helps us to know the lead coefficient. What's different about this one than the last three we've done? It doesn't have parentheses, which means it's not factored, which means you have to do the factoring. Okay, so this is not factored. You're going to have to do it. But can I still tell what the LCT is? Sure. What's the LCT? What's the lead coefficient? Negative 2x cubed. You don't have to do any, you don't have to think about it. Okay, that's the easy part. When it's not factored, okay, so that tells me that there is a reflection. It tells me the right side goes down. And because it's an odd power, then the left side is going to have to go in the opposite direction. So the left side is going to go up. Okay, that's the easy part, because I just get to take the lead term and put it right there. I'm going to have to work for my factors. All right, what do you notice all of those have in common? Okay, they have a negative 2. Anything else? They have a negative 2 and an x. All right, so let's take negative 2x out. That's going to leave me with x squared minus x plus x. Right? Oh, I did it wrong. I copied my notes wrong. Hang on. This should be a plus. Okay, minus 2. Okay, so I did GCF on that. What else do I have to do to it besides just GCF? I got to do star. All right, so we'll set up a star. Set up a star over here. I've got 1 and negative 2. That means it has to be 2 and negative 1. Okay, we do the star. We fast forward. We pretend like we've done it all the work already. We're going to skip that. All right, so we end up with x plus 2 and x minus 1. Now I should be able to get all my zeros from there. I should have 3. Okay, how do I know that there's supposed to be 3? Because the lead coefficient term was power 3. So the roots should be 3. The curves should be 2. All right, my 3 roots are going to come from my star factors. So let's now look at, now that we've got the factors, we look at the first factor part, the second factor part, and the third factor part. So my first factor part, negative 2x, when I set it equal to 0, I'm going to get 0. My second factor part, I'll set it equal to 0, I'll get negative 2. And my third factor part, I'm going to get 1. So now we have the 3 roots. And we can sketch on an x-axis without the y number line. So I just have 0, 1, and negative 2. I don't have to put little stars by any of these because none of these are multiplicity. They're all single roots. There was nothing that was a plus or minus, so this is all fine. The right side is going to go down. The left side is going to go up. I need 2 curves, and I'm just going to pass through all these points because none of them are starred as a double root, so I simply pass through. And I have my first curve between 0 and 1, and I have my second curve between negative 2 and 0, and my second curve between 0 and 1. And then your graph is done. Okay, our last example. Which ones do you like better? The ones that you have to factor first or the ones you don't have to factor first? I think they both have. If it's factored, it's harder to tell the lead coefficient. If it's not factored, it's easier to tell the lead coefficient, but it's harder to tell the roots. So they both have pros and cons, I feel like. Okay, last one. Okay, we're going to sketch negative 2x to the 4th plus 2x squared. And so just kind of think through, okay, roots, how many curves will it have, and what's the LCT? So this is the form. It's easy to tell the LCT. The LCT is the lead term, so it's negative 2x to the 4th. That tells me that there is a reflection. And then it also tells me both sides are down. And I know that because it's a degree 4. I know that the roots should be 4 because of the degree. And I know the curves should be 3. I have to find my roots by factoring. So I'll do some side work over here. What do you notice we can take out in common of this one? What do you see, Ben? What do you see we can take in common out of that? Okay, I could take a 2, and I could take an x squared. When I take out a 2 and x squared, I'm left with negative x squared plus 1. We're going to set each of those equal to 0. So we'll set 2x squared equals to 0. That means x squared equals to 0. What's x equal to? Plus or minus 0. Okay, so now you have a double. There's your first double. Okay, on the other one, we'll set negative x squared plus 1 equals 0. We'll subtract on both sides. So now I have a negative on both sides. I'll get rid of the negative on both sides. And I'll use the square root again, and I'll have plus or minus again. So I have my answers to my roots are 0, negative 0, 1, and negative 1. So when we graph now we're to sketching. Okay, we've got negative 1, positive 1, but 0 and negative 0, I'm going to put a little star to myself right there. That is a multiplicity 2. That is a double root. Okay, multiplicity 2. Both sides are down. Left side is down. Right side is down. I pass through negative 1 and curve towards 0. I pass through positive 1 and curve towards 0. And then at 0, instead of colliding, I have my final curve because of the bounce that happens because of the multiplicity. And so then you end up with a graph that looks like that.